Hello guys, welcome back to my channel, Mason African Motives, working on engineering science and force. So in this platform, we are going to focus on the question paper, which was written in February 2022, that is on dynamics. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having for Mason African Motives. Okay, so let us quickly rush through the question and see what we are given. We are given a 4.1, a car with a mass of 1,1 ton accelerates uniformly from rest to 95 kilometers per hour in 85 seconds, up an incline of 1 in 15. Okay, so it's actually up an incline of 1 in 15, something like that. So, okay, let's just see what we are having, if this information is going to be useful. So we are given something like this, as an up an incline, and we have the mass, which is 1,1 ton. So this is 1,1 ton, where we are supposed to convert this mass to kgs. So how are we going to convert this? We actually know that in a ton we have 1,000 kgs. So how are we going to convert this 1,1? You're going to multiply by 1,000. Okay, that's 1,000 kgs. So you're going to multiply by 1,000, which is going to give you 1,100 kgs if you multiply properly. So it's 1,1 ton multiplied by 1,000 to convert to kgs. So you're going to obtain 1,100 kgs, which is actually the mass. Okay, so you're given the mass in this case. What else do we have? If you are to cross-check, it accelerates uniformly from rest. Take note, it's from rest, which means the initial velocity is 0 from rest. Okay, so from rest, initial velocity is 0 meters per second. Okay, up to 95 kilometers per hour, which is the final velocity, because this is from rest to, so 2, that's your final. Okay, so this is, you can write as v, or you can just write different ways. Someone can write as v initial and vf, or you can just write u and v. Okay, so this is 95 kilometers per hour. But you have to take note here, guys, we are supposed to have this velocity in meters per second. So how are you going to do that? You're going to just divide by 3,6. Remember the relationship between kilometers per hour and meters per second, because you're supposed to have meters per second. So you're going to divide by 3,6. So the moment you divide this by 3,6, you are going to obtain your velocity now in meters per second. Okay, so take note about this part, it's very, very important. So you're going to obtain 26,833, if I'm not it's 389. Okay, 26,389 meters per second. That is what you're going to obtain. So take note, guys, about these values. You have to cross-check properly. It's because of the light that I'm using. I'm having too much light, so if I indicate the calculator is not going to show properly, but this is the value that you're going to obtain, 26,389 meters per second. Okay, let's list the information in 85 seconds. So you have got the time, which is 85 seconds. Okay, so you can just write this as 85s, just like that. Okay, up an incline of 1 in 15. We know that when you're given an incline of 1 in 15, it means that's your 1 and that's your 15 opposite and adjacent. Okay, so let's say the first question is, calculate the following: the acceleration of the car. Okay, the acceleration of the car. What, with this information, guys, that I'm having here, I have the initial velocity, the final velocity, the time. It means I do not have any, I can't use any information about this mass. I can just use this information direct. I can just use this information direct. Okay, remember from your linear motion equations that you have, actually velocity, the final velocity is equivalent to u plus at. Using this formula, I want you to see something, because you have the initial velocity, the final velocity, and the time. And what do you need in this case? You need the acceleration, which is a. So you can simply make a the subject here. Okay, let's make a the subject here. v, u to this side is going to be minus u, then you divide by a, which is equal to t. So that is going to be the time. We need a, not t. We need a there. So this is going to be t, and this is your a. Take note, guys, we need to find the a. So you're going to make a the subject. That is going to be v minus u over t. So let us substitute our v, which is the final velocity. The final velocity is the one that we converted here to meters per second, which was 26. So it's 26,389 minus the initial velocity, which is 0 in this case. Okay, so we've got 0 over the time which was taken. Okay, so we've got the time here of 85 seconds. That's our time. All right, so we can actually use the calculator in this case. So guys, like I was saying, that the display that I'm having here, so you're going to obtain something like 0,31045, something like that, and so on and so on. So you can actually round off this, or you can just put these to 3 decimal places or 2 decimal places. So 1, 2, 3, this 4 can not change this 0, so it's going to be 0,310. You can write this 0, you can just leave it like that. Okay, so that is the acceleration that you are calculating, of which we know that acceleration is measured in meters per square seconds. Okay, so that is going to be units, or you can write this as meters per square second like this. So it's still one and the same thing. Okay, so you got the acceleration. I don't see any use of this diagram, in fact. Okay, the kinetic energy on 4.12, so this was 4.11. Okay, so this was 4.11. Okay, and on 4.12, the kinetic energy after 85 seconds. Okay, so we need the kinetic energy from your formula sheet. It's because I'm having a lot of papers that I was using and I don't know where this formula sheet is, but we know that the kinetic energy, let us write down the formula so that we can be together here. So we have our EK. This is 4.12. Let's just write like this. So the kinetic energy, we know that is equivalent to half mv squared. Okay, so these formulas, actually you are having them on your formula sheet here. This is your kinetic energy. Okay, so with this formula, let us substitute the information, guys, because we have this information. The mass is there, so we are going to have half mv squared, which is half of mass, which is the mass of 1,100. Okay, so that's 1,100 multiplied by v squared. So this v that you're talking about is the final, is the velocity. This one, the final velocity, that is 26. So you got 389 everything here to the power of what? Of 2. So you apply your calculator, use your calculator properly. In this case, you are going to obtain this decimal 383,008,6 something like that. Okay, now you can just round off to this number here, which is going to be to the nearest whole number, so it's that it can be 383,009, something like that. Okay, it's guys, to leave this 8 is going to be so weird, so you have to round off at least this to 9, and that's kinetic energy, which is measured in what? In joules. Okay, so that's our answer. And also this answer is so easy, we can just write in kilojoules. Remember, 3 commas like this is going to be 383,009 kilojoules, or you can just leave this answer like that, guys. Okay, you can just leave this answer in joules, or you can just write this in kilojoules. Okay, so that's how how you're supposed to answer this question, actually. Okay, then on 4.2, you were given a hoist lift, a crate of 250 kgs from rest. Take note, guys, let us take information. Always try by all means to use the information that you're given. So this is 4.2, the information of 4.2. What are we given? We have got the mass of 250 kgs. All right, then what else do we have here? It's from rest, which means just like this one, from rest, the initial velocity there is 0. So the velocity at that moment is 0 meters per second. Okay, take this one. It lifts a crate, take note, to a height of 12 meters. Okay, so this is the height that is going to be lifted, which is 12 meters. So it's like something like this. It is lifting something upwards like this. Okay, so take note, guys, when you are lifting something upwards, always you're going to be forcing the downwards forces and so forth. So you got the time to lift this, which is in 10 seconds. So the time to lift this is in 10 seconds. And with uniform acceleration, so we do not have the acceleration, but we are told that it is using uniform acceleration anyways. Then calculate the following: the gain in potential energy. So we need the gain in potential energy. Okay, so just like what I showed you from the formula sheet, these formulas you'll be given, guys. This is the gain in potential energy, which is mgh. Okay, so gain in potential energy, which is 4.21, is going to be mgh. That is mass times the gravitational acceleration times the height. Okay, which is the height. This one is the height which you are given of 12 meters. And like I was saying, that since you are lifting up, there's going to be the gravitational acceleration which is pushing downward, the force, gravitational force. Okay, so we've got m, which is the mass of 250. So we've got 250 by the gravitational acceleration, guys. We know that it's 9.8 times the height, which is 12. Okay, so that is going to be the potential energy. Okay, so also using your calculator properly, you are going to obtain something like 29294,000. These are 00s. Okay, 00 like this. Okay, which is in joules. Okay, then you can round off this. We can not round off. You can convert to kilojoules if you want, or you can just leave your answer like this. Still, it's fine. So to kilo is going to be 123, which is 29.4 kilojoules. Okay, so this is going to be the potential energy if you convert to kilojoules, or you can just leave it in joules like that. So that's how they ask these questions. Simple anyways, but you just need to revise so that you understand the information. Then we need the power to hoist the crate, which is to lift the crate. Okay, so what is the power now? Okay, we know that power is work done over the time. Okay, do we have something like that here? Actually, we just have this one and this one, and I don't know if you cross-check properly, you can see the formula there for power. But we know that power is work done over time. So let's see that one if we can work with it. Okay, that's 4.22. We know that power is equivalent to work done over the time taken. Okay, where are we going to have the work done, guys? Where are we going to have the work done? Remember, work done is actually the force times the distance. Okay, so if this work done is equal to force times distance, that is force times distance like this over time. This distance is actually the height, which is your the height where you are lifting, because you are lifting this crate in this height of 12 meters. That's your distance. So, but this force here, where are we going to have? Remember, force is actually mass times what? Acceleration. But this time we can't use this formula. Why? Because you are lifting a crate upwards like this. So instead of using the normal acceleration, you are going to use the gravitational acceleration, where our force now is mg. Okay, so that means in place of this force here, I'm going to replace with mg. So it's going to be mass times the gravitational acceleration times the distance over the time. Everything now is going to give me the power. So guys, we just substituted. Do not confuse this. You can calculate the work done separately. Okay, which is force times distance, which is you first calculate your force here from the mass times what? Times the gravitational acceleration. Then you multiply by the distance. You choose the way that you want to do it, or you can just write here so that you can just substitute all the values at once. So if you use this part, you're going to substitute the mass now. What is the mass? From the information that we had, the mass is 250 kgs. So that's 250 kgs multiplied by the gravitational acceleration, which is 9,8, multiplied by the height. This distance is representing the height which is being taken upwards there, which is 12. Divide by the time. To lift this crane, it took 10 seconds. So you're going to divide by 10. So by doing so, you're actually finding the value of the power. Okay, so using your calculator properly, you're going to obtain something like 2940 watts. Okay, so you can remember power is measured in watts, so you can leave your answer like this, or you can convert to kilowatts, which is 123, which is 2,940 kilowatts, or you can just write it as 2,94 kilowatts. So that is the power work done over the time. Work done. Take note, guys. So that's how you answer these questions. Try by all means to list the information. Write down the information that you're given. Okay, once you write down the information, it is going to be easier for you to see the formula that you're going to use. It's going to be very easier for you to select the formula. But if you don't list this information now, it's going to be very difficult to actually choose the formula to use. Okay, then on 4.3, you are given an engine with a mass that is an engine there which is a mass of 85 kgs is pulled at a constant velocity of 1,8 meters per second along a horizontal surface with a coefficient of friction of 0.5. Okay, so there's a, let's just list again, just like I was saying, guys, it's best for you to list the information that you are given. So this is 4.3. What are we given on 4.3? What are we given in this case? We need the information that we are given. We are given first a mass of 85 kgs. Okay, so that's a mass of 85 kgs. And what else are we given? It is pulled at a constant velocity. This is the velocity which is like the initial velocity that you are using, or you can just use this as a normal velocity. Okay, so that's the velocity of 1,8 meters per second, normal velocity, along a horizontal surface with a coefficient of friction of 0.5. So you're given the coefficient of friction of 0.5. All right, now the question is asking, calculate the power required to pull the engine. Okay, we need the power that is required to pull the engine. Remember that when you're given a condition like this, that this is a horizontal surface where you're pulling something this way, and there is going to be actually a frictional force that is going to be opposing. So the frictional force is the one that you're actually going to work with in order for you to calculate the power, because remember that power is equivalent to force times the velocity. So this force is the frictional force multiplied by the velocity. But where can we have the frictional force, guys? Where can we obtain this frictional force? That is the question now. Okay, we are given the coefficient of friction, and we know that from the coefficient of friction, we can actually use this combined together with the frictional, with the what can we say, with the weight of the component, because here we are given a mass. This is actually a mass, so we are going to have the weight that is W. Okay, so that means we are going to have the frictional the coefficient of friction multiplied by the weight together to obtain the frictional force. But where are we going to find this weight? Remember, guys, from the previous part also we say this weight is equivalent to mg, that is mass times the gravitational acceleration. Okay, so let's substitute here. We are going to have the coefficient of friction multiplied by mg, which is mass times gravitational acceleration, just like the previous part. And it's going to be easier for you because you're now just substituting the information. You're given the coefficient of friction, which is 0.5, so you can substitute 0.5 multiplied by the mass. I've got the mass of 85 multiplied by g, which is 9.8. all right, so if I multiply these values together, I am obtaining the frictional force. Okay, which is going to give us something like 416. Okay, that's 416.5 newtons. Remember, this is force. So if this is the force that we are obtaining of 416.5 newtons, and previously I say that power is equivalent to the frictional force times the velocity. So you're just going to substitute here because you've got the frictional force, which is 416.5 multiplied by the velocity. The velocity is already there, which is 1,8. Okay, so as you can see, it's a matter of combining a combination of formulas, working with formulas together. Okay, so if I combine these two, I'm going to obtain 749.7 watts. Okay, so remember, this is power, which is measured in watts.